Hello, I'm Patty Simpson with Simpson Math. In statistics, we have some question we want answered. We go out and we collect data, and that data helps us to answer our question. Now, we would love to be able to collect data from our entire group of interest, or our entire population. But many times, that takes too much time, money, or human resources. So instead, we just collect data from a part of our population, or a sample. And here we are looking at different methods for collecting that sample. Particularly, let's look at a stratified sample method. In order for it to be a stratified sampling method, a researcher divides population into separate groups, which we call strata. Then a probability sample is drawn from each group. Anytime I see this word strata or stratified, for some reason I think of dirt. Like I picture the dirt of a mountain, different layers of that dirt. And a stratified sample, we do the same thing. We layer or have groups within our population. And then I picture a big bulldozer or something coming down and drilling down through those layers of dirt, and then grabbing dirt from every one of those layers. And that would be a stratified sample. We've divided the dirt into different layers, and then we've come down and grabbed a sample, a piece of each one of those layers. And that's exactly what a stratified sample does. We divide our population into separate groups and then choose a few members from every one of those groups. Now, there are a lot of advantages to using a stratified sample. A stratified sample can help to reduce the selection bias so that our sample is very representative of our population. And it helps to ensure that a sample accurately reflects that population. And we can even make it more specific. Sometimes we can do something called a proportionate stratified sample, where each one of our sample, our groups, is proportionate. So if this group is made up of 50% of my whole population, then in my sample, I choose 50% of my sample from that group. And if this group over here is just a tiny piece of my population, it's only 2% of my population, then in my sample, I would only have 2% from that sample, or from that strata. So we can even divide up the strata even more carefully in that manner, so that it really does reflect the population. The disadvantages, though, to a stratified method is that the researchers must identify every member in the population to classify them into groups. So if you're looking at a certain, maybe the dirt, and you don't realize that there's a layer down below that you've missed, well, then you may not grab all the dirt from all the different layers. Or if you're looking at people, maybe you miss an entire ethnic group of your population. So that is one difficulty with the stratified sample, is to make sure that you've included all the groups. So here are a couple of examples of stratified samples. Suppose a research team wants to determine the average number of hours a student studies for a test. The team divides the students into majors and chooses a few students from each major. So in this case, the strata are the majors. The groups they've divided them into are the majors. And they've chosen a few students from every group. They chose a few students from every one of those majors. And that's what makes it a stratified sample. Now, they do have to make sure that they've included all of the majors. That's the one thing that the researchers need to be careful of. Here's another example. Researchers want to determine nurses' willingness to care for patients infected with HIV. The researchers divide the nurses by the amount of experience, 0 to 2 years, 2 to 5 years, 5 to 10 years, more than 10 years, and choose a random sample of nurses from each experience level. So their experience level, or the number of years they've worked, that are the strata, those are the groups. and they're choosing a few nurses from every one of those groups. So a stratified sample, we divide our population into groups and choose a few members from each of the groups. Math made simple at Simpson Math. Thanks for watching.